Okay, so we're going to continue our study of quadratics, and we're going to look at factoring quadratics. And the point of this is that eventually we're going to get to where we can solve quadratics, like we were doing before with our graphing calculator. So when you have a quadratic equation, remember quadratic equation is when you have an x squared term as the highest exponent. So 2 is the highest exponent in this problem. To factor, we want to just focus in on the x squared plus 3x minus 10. When you're factoring, you want to make sure your equation is equal to 0. So we're going to make this equal to 0. And then we're going to factor the left-hand side. So factoring is what we were working on when we did those sum and product puzzles. So how this works is that the number at the end is that number that we're multiplying and trying to figure out the factors that multiply to give you negative 10, and then they're going to add up to the middle and give you positive 3. So when you're factoring, you're thinking of what numbers multiply to give you negative 10. So you got to go through your factors. You've got 1 and 10, or 2 and 5. One of those numbers will have to be negative in order to make it negative 10. So when I look at my factors list, I've got 1 and 10, or 2 and 5. There's no combination of 1 and 10 if I add them or subtract them to get me to 3. 1 plus 10 is 11, and 10 minus 1 is 9. So that's not going to work. So looking at 2 and 5, I'm thinking these are my options. So I've got positive 2 or negative 5, or negative 2 and positive 5. Remember, when we're dealing with these, whatever the sign is of the number in the bottom, the bigger number should have the same sign. So in this case, the 2 will be negative. So my two factors that multiply to give me negative 10 are 5 times negative 2. And when you add those two together, they give you 3. So I can rewrite this. This is called factoring a quadratic. I can factor this into two things that multiply together to give me the original equation. You always start off with x and x if your first term is x squared. Because if you think about it, x times x is x squared. And the other two numbers we have there are plus 5 and then minus 2. So now this equation is the same thing as this, but this is called factored form. And eventually we're going to look at how we solve this and how we can turn this equation back into this to check it. But for now, we're just going to work on factoring and turning these equations into the factored forms. So we'll use that little strategy, if it helps you, of making the x and putting the number at the end on the top and the middle at the bottom, and see if we can use that to help us factor. So let's try the next one. I'm going to draw my x over here on the side. So I need the numbers that multiply to give me 3 and add to give me 4. So two numbers that multiply to give me 3 are really only 1 and 3. And if I check that, 1 plus 3 is 4. So those are going to give me the factors inside my parentheses. So remember, if your term starts off as x squared, you're going to start with an x and an x. And now I'm going to use my two factors that I found to get plus 1 and plus 3. We'll eventually get back to how we know this is correct, but right now I just want to see if we can start factoring. For the next problem, so what multiplies to give me 24 and adds to give me 11? So you got to think of your factors of 24. You got 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Everything's positive, so I don't have to worry about negatives in this problem. 1 and 24 is too big. It's going to give me 25. 2 and 12 gives me 14, so that doesn't work. So I think it's going to be 3 and 8, because 3 and 8 gives me 11. So my factors, if I rewrite this, is going to be x plus 3, and x plus 8. Some of you might be wondering, can I write it as x plus 8 and x plus 3? You could, because remember, multiplication, it doesn't matter the order you multiply, you'll still get the same answer. Let's try another couple examples. So what numbers multiply to give me -2 and add to give me +1? So the only numbers that multiply to give me 2 are 2 and 1, right? So it's 2 times 1. I need them to be negative when I multiply, and then when I add them, I need them to be positive. So that means that my smaller number should be negative, because when I add them, I want the answer to be positive. So there are my factors. I've got x plus 2 and x minus 1. This time I need numbers that multiply to give me -27 and add together to give me 6. So again, I'm going to think of my factors for 27. I've got 1 and 27, or 3 and 9. So I don't think 1 and 27 is going to work at all. I need these to be positive when I add them, but negative when I multiply them. So that means that my bigger number has to be the positive. So 3 is going to be negative in this case. So the factored form, remember we started off as x and x, and then we're going to just fill in our factors here. X minus 3 and x plus 9. Let's try the next example. So I need two numbers that multiply to give me 21 and add to give me -10. So now in this case, the top is positive, so that means that my two numbers have to be the same sign. So, and I know the bottom is negative, so that means they both have to be negative. So two numbers that multiply to give me +21 are -3 and -7. And if I add those together, that gives me -10. So the factors here, remember it goes x minus 3, x minus 7. Trying it again for the number 6. Whatever the last term is, that's what we're looking for to multiply, and then that should add to be the middle. In this case, it's -1. So what numbers multiply to give me -20, and then add together to give me -1? So the only numbers I can think of that multiply to give me 20 are 1 and 20, 2 and 10, or 4 and 5. So 1 and 20, no matter how I combine those, are just not going to get me to -1. And 2 times 10 is also too big of a difference. So I'm left with 4 and 5. So I know 4 times 5 is 20, but to make it -20, I have to multiply by a negative number. And since my sum is negative, I want the bigger number to be negative. Because now -5 times 4 is -20, and -5 times plus 4 is -1. So my factors here are x minus 5 and x plus 4. Here I need two numbers that multiply to give me 25 and add to give me 10. So the factors here are going to be 5 and 5, because 5 times 5 is 25, and 5 plus 5 is 10. So I can rewrite this equation as x plus 5 times x plus 5. Let's try the next one. So multiply to give you +16 and add to give you -8. So the numbers for 16, I've got 1 and 16, 2 and 8, or 4 and 4. So notice this number is positive and this is negative, so that means that my two numbers have to both be negative. So 1 and 16, and they're both negative, will give me too big of a number. -2 and -8 will give me -10, so that means I'm left with -4 and -4. So my factors here are x minus 4 and x minus 4 equals 0. take a look at number 9 and 10. These do not look like these problems up here. They don't have the third term here where they're adding or subtracting a number without an x. But these numbers do have something in common, and we can also factor these guys. So factoring with these problems is kind of like reverse distributing. So I'm trying to figure out what number or letter do they have in common that I could pull out from each of them. So looking at the x squared and the 8x, I see they each have an x term. So I'm going to pull out x. So I'm reversing the distribution. I'm pulling x out. I'm dividing each of these things by x, essentially. So if I take out an x from here, that leaves me with 1x. And if I take out x from here, that leaves me with -8. So we just factored this. We just reverse distributed that problem. It's kind of like we were doing up here, but a different way of factoring. So same thing for number 10. I want to pull out something that I see they have in common. So again, I see they have an x in common. But then it's more than just x, because I can divide these numbers by a common factor. And the common factor that they each have is 3. I can pull out 3 from each. So if I divide this by 3x, all that's left here is an x. And if I divide this by 3x, 15 divided by 3 is 5. So I just reverse distributed, or it's called factoring, those quadratics. So I want you to get some practice with this, just factoring for today. We're just going to factor the new equations with the ones that were given to you and see how you do. Good luck.